All right, so we are working in Chapter 1, Section 6 for IM2, and this is solving an equation in the form x squared plus bx plus c equals 0. So the first thing we come to here is just a few notes. We have, let's see, how to factor trinomial in the form x squared plus bx plus c equals 0. Ooh, excuse me. To factor the trinomial of the form x squared plus bx plus c equals 0, you must find two integers that add to b and then multiply to c. And what it means by that is this b and this c. So I just shouldn't have included the x there when I wrote that out. So here's our example. We have x squared plus 14x plus 24 equals 0. What two integers have a product of 24, so product of 24, and a sum of 14? So if I actually think of that, what I like to do is I take that 24 and I break it down into its factors. So the first one is always 1 times the number that you're looking at, 1 times 24 in this case. And then 2 times 12 would be the next one, 3 times 8, 4 times 6, and now the next one would be 6 times 4, so we don't need to write that. We already wrote 4 and 6. So here are all my factors. Here are my possibilities in this case. And I need to know which two factors are going to add up to 14. Saying that funny. They multiply to 24. We need the ones that add up to 14. And since it's plus and plus, we know we have all positive. So the only option would be 12 and 2. So that's where they get the options. So now that we know it's 12 and 2, we break them down. So the very first one, to get x squared, we have to have x and x. And then we know to get the next two pieces, we're going to need 12 and 2. So here's plus 12, here's the plus 2. So that's why we break it down into the two factors. So as long as we have just a variable squared on the beginning, it's going to be just that variable broken into its two pieces. Once we start adding a coefficient there, that does get a little bit more complicated, but definitely doable. Just one extra step kind of thrown in there where we have to take into account. But for now, we're just looking at just a variable squared, and then we break down the factors of that last term to add up to that middle term. All right, let's go ahead and practice this on number 1 and 2. So we have our pieces here, and I like to write it out so I already know. So since I have c squared, I know it's going to be c and c. I already can fill those in. It's plus and plus, so I can go plus and plus. I don't have to worry about that. Now I need to look at what factors of 9 are going to add up to 10. So I have 1 and 9, 1 in the number, and then I can also break it down in other ways. In this case, only 3 and 3. So the only ones that are going to add up to 10 would be 1 and 9. So I'm going to have 1 and 9. And then I want to solve it. So I have c plus 1 equals 0, c plus 9 equals 0. So I need to make sure I'm going to subtract 1 from each side. Any number minus itself is 0, so c equals 1. And then minus 9 on both sides. Any number minus itself equals 0, and then negative 9 on this side. So we have negative 1 and negative 9. Again, I knew there was going to be two answers because it's the degree of this equation to start with is squared. That tells me I'm going to have two factors there, or two answers. All right, so now we're going to look at this one. I can't factor this until it equals 0. So I need to subtract this 27 on both sides. So I have x squared minus 6x minus 27 equals 0. Now I can factor this. Now I can go like this. And it's x squared, so I know it's going to be x and x. And I have to look at 27 to see which factors of 27 are going to work. So 1 in the number. I can't do 2 because that's not even, and we want whole numbers here. We don't want any decimals. But I can do 3 and want to make sure I'm doing that. 3 and 9. I almost lost my train of thought there. And that would really be the only two factors here. Nothing else really works. Whole numbers anyway. We can get a whole lot of decimals, but we need whole numbers. So we want them, in this case, because it's subtraction, there's a minus sign here and a minus sign here. I know I'm actually going to have 1 plus and 1 minus. Because that's the only way, if I multiply the last terms here and I end up with a negative number, so I should end up with negative 27, well, that means one needed to be positive and one needed to be negative. And I also am adding up to 9, which means if one's positive and one's negative, and I want it to be negative, sorry, I'm adding up to negative 6. I'm losing my train of thought here a little bit. That when I look at these guys, I want to make sure the bigger number is negative. Because negative 9 plus 3 gets me negative 6. So I'm going to put the 9 by the negative and the 3 by the positive. So you have to pay attention to that once you start getting these negatives. It's not just plus and plus anymore. Now I have to make sure I put it in the right place. Because you might have the right numbers, but if I flipped these, then I'd end up with positive 6 here. I'd still have negative 27 on the end, because it'd still be a positive times a negative, but my middle term would be incorrect. So just pay attention to that. If you're subtracting two numbers and you end up with a negative, the bigger number needs to be negative. If it's a positive, that means the bigger number needs to be positive. So it's just kind of patterns there, I guess you can memorize or identify. All right, so now I have x plus 3 equals 0, x minus 9 equals 0. I go negative 3, or minus 3. These guys cancel, and I have x equals negative 3. I'm going to add 9 on both sides on this one. So I have x equals 9. Alrighty. Let's see. I'm going to move down here. So now we have a word problem. So we have a triangle has an area of 36 square feet. And if the height of the triangle is 6 more than its base, what are its height and its base? So we need to kind of write this up so that we get we can write it all in a formula. So we need to think about it. So they don't tell you this one, but if you didn't know how to write the area of a triangle, you could always look that up. But area of a triangle, we have area equals 1/2 base times height. So this is always how we calculate the area of a triangle. And then we have height, base, and area. So we have 3 pieces here, right? 3 variables. They told us that the area is 36. So we know that already. And then they told us that the height of the triangle is 6 more than its base. So I know the height is 6 more than the base, but what's the base? Well, in this case, since we're using base to calculate height, we're just going to say base is b, and height is 6 plus b. So now we have our 3 pieces, and we can write an equation here. So instead of a, I'm going to write 36. Instead of b, well, I'm still going to write b, right, because that's still a b. But instead of h, I'm going to replace that with 6 plus b. So I'm multiplying by a binomial there. So I'm substituting some pieces in here, right? B didn't really change because b still equals b. We're identifying that one. But h changed and a changed. They're still the same. They represent the same thing. We're just working them in so we can solve this equation. So now we have 36 equals 1/2. We're going to multiply all of this together. So we're going to distribute this b. Okay, b times 6 is 6b. I'm going to put parentheses around this actually, so that we know we have to do 1/2. And then b times b is b squared. All right, and now we're going to do 1/2. Although, what we can do with this, instead of having to divide by 2 and deal with this fraction, we can get rid of the fraction. So this is, the idea of a fraction is divided by 2. So 1 divided by 2, or this whole thing divided by 2. So I can just multiply by 2 on the right. I have to do the same thing on the left. So what I'm doing is I'm taking this fraction and I'm canceling it out, because here's division, here's multiplication, so they cancel out to 1. And now on this side, I have 72 equals 6b plus b squared. So it just kind of helped me eliminate that fraction to make this a little simpler looking, a little easier to solve. So now I'm going to bring this over here and I'm going to write it in the right order. I also need to subtract the 72 over to this side. Because remember, we need it to equal 0, just like this one. We don't want any other numbers on the other side. So now I'm subtracting the 72 and I have 0 equals, but as I rewrite, I'm going to write it in the right order here. So I'm going to have b squared plus 6b, oops, b, that's funny, it looked like 66 there. I'm going to erase that and do that a little neater. 6b, and then minus 72. All right, so I just wrote it greatest to least as far as exponents go, so that that's a little easier for me to line up. Now I can factor this and actually get an answer because I can say equals 0. So there's just a variable squared, so I know I'm going to separate that b and b. But I have to take 72, and I have to figure out what factors of 72 add up to 6. So we have a plus and we have a minus here. So I know I'm going to have a plus and a minus. So I'm actually subtracting 2 factors to get to 6. The bigger one is going to have to be positive because I want a positive number in the middle. So we have to go through. It's not going to be 1 and 72, but that's one of our factors. 2 and 36, we hopefully remember that from over here, right? That's also not going to get us 6 when we subtract those. We have 3 and let's see, 20. So it goes in 2 times and 4 times, 24. And then we also have 4. 4 doesn't work. Oh, 4 does work evenly. Sorry, I was thinking that it doesn't work evenly. So we have 4. So we still don't have anything that's going to equal 6. I'm going to keep going here. Can't do 5 because it doesn't end in a 0 or 5. We can do 6. So here's a multiplication trick. If you didn't know that, if a number can divide by both 2 and 3, it can divide by 6. So 72 divided by 6 is 12. Let's see, do we have any other ones? We do have. So we can't do 7, and there isn't really a 7's trick. You can just divide that one. You can do the multiples of 7 or use a calculator on that one. You'll get a decimal, though. So we don't want 7, but it does divide by 8. So 72 divided by 8 is 9. All right. And now we would just start going, if we did 9, we'd have 8. Well, we don't need to write the factors twice. That's just too much. So now we want to look at which factors bring us down to 6 when we subtract them. Well, the only ones that would work would be 6 and 12, because 12 minus 6 is 6. Make sure to get a positive 6 in the middle here. We would need 12 to be positive and 6 to be negative. We're subtracting 6 from 12. So positive 12, negative 6. And then we have b plus 12 equals 0. B minus 6 equals 0. We're going to subtract 12. And these guys cancel just like they have on all the other ones. We have negative 12. And then plus 6. So these guys cancel again. We have b equals positive 6. All right, so now that we have a scenario, we have to talk about what's called an extraneous solution. Meaning it's a solution, but it really doesn't apply to this situation. So if we're talking about measurements and lengths, we can't have a negative value. So we can't have the base of a triangle. If we drew a triangle like this, and here's the base and here's the height. I know that's a really ugly triangle, but this base can't be negative 12 feet long. That doesn't make any sense. So this solution is extraneous, and we cross it off. It's not an actual solution. But b equals 6, that is a solution. So in this case, and I drew this backwards actually, because the base and the height should be the other way like that, and I know I'm drawing right on top, but the heights should be bigger than the base based on this problem. So the base is 6 feet long, and the height, remember, we're going to bring this guy down here, boop, like that. I know it's a very ugly arrow, but 6 plus b, well, b we just found is 6. So I don't know why I wrote plus sign there. Darn it, go back. There we go. So h equals 6 plus 6, which is 12. By chance it's 12. That doesn't have anything to do with this one. That's not going to normally happen. It's just a coincidence. But hey, that's perfectly fine. So I believe, is that all for section 6? Or do we go to the second page here? Nope, that's section 7. All right, that is all for section 6. I will see you in section 7.